All right, so this is a very brief lecture. 6 factors that influence blood pressure. That's all it is, folks. 6 factors that influence blood pressure.
I thought you said everything influenced blood pressure besides blood type.
That's true, but when it comes down to it, all those can boil down to pretty much just these 6 things, regardless of what they are. In some way, they're going to influence these 6 things. Let's see here. Our bodies work very hard to keep blood pressure at a stable level. Now, what was that average that I gave out the other day? You remember what it was? 120 over 80 is pretty, I mean, is good. You know, it can be a little more, it can be a little less, it'll still be okay, but at a stable level. And it's tricky to do this because of the demands we place on our body. Last night, you were trying to sleep, you were laying down, probably, and doing that means your body does a different thing with its blood to keep its blood pressure. Then when you stand up, you might notice this if you stand up too fast, that your head feels kind of weird. You know, if you get up from lying down and you immediately go into a standing position, you forced your body to try to change the way that it was pumping blood, because while you're laying down, your body can easily get blood to the brain without as much effort. But then when you change your position, it has to force that against gravity. And sometimes it doesn't keep up as quickly, and you have a little trouble with that. The factors include first one would be blood volume. What do I mean by that? Yeah, very simple. How much blood you have. The quantity of blood. Okay? Quantity. An increase in blood volume would result in an increase in blood pressure. The opposite of that is also true. A drop in blood volume would cause a drop in blood pressure. Now, I want to put in parentheses 2 things that influence this. Regulated by kidneys, influenced by salt. Your kidneys are not just, good for making pee, which they do. They make a lot of urine over your lifetime. They basically, they're like your inline oil filters, if you will. They take the blood from your bloodstream, filter it through, and they remove the excess water and waste products from your blood, and then drain that out of your body as urine. So that's how your kidneys play a huge role in regulating your blood pressure, is by controlling the blood composition and blood volume. But I wanted to make a note here that it's also influenced by salt. People with high blood pressure, they recommend that they begin a lower sodium diet. This has to do with tonicity. If you remember back in biology, you guys were talking about hypertonic, isotonic, and hypotonic solutions. If we eat too much salt, what happens is that salt gets into our bloodstream, and that draws fluid out of our cells, because the blood then becomes hypertonic to our cells. So it pulls it out of the cells and interstitial fluid, which raises our blood volume, thereby raising our blood pressure. So one of the simplest and cheapest medications they can prescribe for someone with high blood pressure is a diuretic, which is basically some sort of drug that makes you go pee. And so decreases blood volume and thereby decreasing blood pressure. Next is an easy one, cardiac output. Cardiac output. If we increase cardiac output, what's that going to do to blood pressure? Uh-huh. Will raise the blood pressure. So if the heart's beating faster, for example, during exercise and things like that, you'll see an increase in blood pressure as a result. Now these next two here both start with vessel, and I'm going to have you put a little star next to those because these are going to be the only two that are inversely proportional. It means that one goes up, the other goes down. They are vessel diameter as we decrease vessel diameter, then blood pressure will increase. Decrease vessel diameter, then blood pressure increases. The pressure dynamics here are very simple. It's just like any sort of hydraulics issue. Think about if you are in the yard and you have a garden hose in your hand and you wish to saturate your friends that are beyond the reach of where the garden hose normally will flow out. What do?
Lift it over your head.
Put your thumb over it.
I even stick my thumb over the end. And what happens then is I have taken this inch diameter of garden hose and decreased that down to, half an inch or whatever, or even less. I decrease the diameter, and I've done what to the pressure? Increase the pressure, and it can shoot a greater distance as a result. Okay? Similarly, and this mechanism by our body standard is the one that is used the most often to regulate your blood pressure by regulating the diameter. Remember, we have those blood vessels have three layers: the tunica intima, tunica media, and tunica externa. The media layer has a lot of muscle in it, has a lot of smooth muscle that responds to both nerve impulses from the brain and also responds to chemicals that go through the bloodstream, like adrenaline or epinephrine, things like that can cause those to constrict, and they will increase blood pressure. Most medication that is prescribed to lower blood pressure acts on this. Basically, limits the body's ability to naturally constrict its own blood vessels. One of those categories of drugs is called an ACE inhibitor. There is a hormone in our bloodstream called angiotensin, and it does a pretty good job of clamping down on blood vessels. It gets converted to something more powerful called angiotensin 2, brilliant name, right? By an enzyme called angiotensin converting enzyme. And basically there are drugs called ACE inhibitors that basically stop the action of angiotensin converting enzyme from converting 1 into 2, and so it's not as powerful of a vasoconstrictor. So a lot of drugs work in that way to keep blood vessel diameters at a normal level so that or keep the body from clamping them down any more than necessary. The next one is one that we really can't do much about, but it changes with age and it's worth mentioning, and it is vessel elasticity. Basically how stretchy your vessels are. Okay, if we decrease elasticity, we will thereby increase blood pressure. Decreased elasticity will cause an increase in blood pressure. This happens over time. When you're young, your blood vessels are super stretchy. As we age, they become less stretchy. As we get a lot older, they harden. The blood vessels actually harden over time. So they go from being like flexible rubber hose to being more like PVC pipe as we age. And so there's no give for the recoil of blood. It causes pressure to increase. Next is blood viscosity. This is just another word for what?
The thickness of the blood?
Uh-huh. The literal thickness of blood. Okay. An increase in viscosity would cause what to happen to blood pressure? An increase in blood pressure. If you have more cells per unit volume than you have plasma or fluid in there, you're going to have an increase in viscosity. And the converse is true too. If you get more water versus cells in the bloodstream, then you'll have a decrease in blood pressure, and so on and so forth. Oh, I should have put a star by this one because this also is an inverse relationship. One goes up, the other goes down. And the last one, number 6, total vessel length. Basically, this has everything to do with the size of person. Someone who's really, really small is going to have less blood vessels than someone who's a lot larger. And this goes all the way up to someone who's, a kid and an adult, someone who's just a normal adult versus a basketball player or a football player who's like 7 feet tall. And
Andre the Giant.
Yeah, Andre the Giant can have way, way more blood vessels. But here's the thing. The more blood vessel length that you have, the more blood is in contact with vessel walls. As a result, increase in total vessel length is going to cause an increase in blood pressure.
Is that why giants have shorter lifespans than normal human beings?
Yes, that has a lot to do with it. The blood pressure it takes to support that, and everything. We're really not set up to be enormous people, it takes a toll on all of our systems. Our heart has to work that much harder. Our lungs have to work that much harder. Our liver has to work that much harder to process all of it. It just takes a greater toll on everything.
But if you oversized every system of the body, would that make up for the size, or would that just make it worse?
Well, there is some give and take on that. For example, in an infant, their aorta is probably only as big around as my pen, but in me, it's probably about the size of a garden hose. And in someone that was, like a giant or whatever, would have a aorta that's even bigger than that. So those would be scalable to where, one could make up for the blood pressure, like in that regard. But I don't know that every system of the body is scalable like that, because some things involve chemical reactions that have a specific sequence that have to occur, and you can't really make up for that with just more stuff. You know what I'm saying? That's a good question, though. As we decrease weight, though, and this is something I want you to get a hold of, someone, if they were like 600 pounds and they lost, a couple hundred pounds, they would lose blood vessel length, okay? Their body would reabsorb or break down those blood vessels if they're not needed. Now, it wouldn't be these, okay? It's not going to get rid of these blood vessels. These are here to stay. Your major arteries and veins will not change in your lifetime. However, you will increase in your number of arterioles and capillaries and venules and things like that. And those are constantly changing in a growth process of blood vessels called angiogenesis, which is, again, not static. It's a constantly changing thing. So here are the main six factors. And pretty much everything that influences blood pressure influences it by changing one of these in some way. So that's it for the factors today.